Hey everyone, today we're going to go over the configuration of single area OSPF routing. So we're going to start off by adding loopback interfaces to each of our routers, and then setting up a router configuration that is advertising all of these routes within this network topology, all of these networks, I should say, as well as the networks pertaining to our loopback interface addresses. So once we get that configured, we're going to move on to manipulating a route from this R1 router to load balance between R2 and R5 right here, heading to this specific network. And then once we're done with that, we're going to do something called default route injection from this router right here in order to allow these routers to access the internet right over here. So let's get started. I'm going to open up R1's CLI right here. And first and foremost, when OSPF is in the midst of forming adjacencies with other routers, syslog messages will come up and sort of interrupt you in the middle of a command. It can get a little jumbled and confusing at times, so what we want to do first is jump into our line console configuration and enter the logging synchronous command. That way we can avoid that little bit of mess, and you can just pick up right where you left off once that syslog message comes in. So press enter, and then I want to configure the loopback interface with the interface loopback 0 command and apply an IP address. I'm going to do the 192.168.0.0 private IP addressing, and the host portion is just going to adhere to like the router number. So we got R1, so I'm just going to put R right there. And for loopback interfaces, you want to apply a /32 mask. 255.255.255.255. Sorry, we have the loopback set up on there, and then we want to jump into our OSPF router configuration. So we enter OSPF, router OSPF, and then a process ID. Process ID, pretty much it just symbolizes like different instances of OSPF. You can have multiple on a router, but for the sake we're just doing one, so we're going to enter 1, and then you advertise the routes with the network command. So we're going to do the all of these networks starting with 10 in the first octet can be covered with a /8 mask, because as you can see there's changes within like the first 3 octets and they vary, so we want to cover that with the /8 mask. So network.10.0.0.0, and then for OSPF configuration with the network command, they use wildcard masks. So instead of that dotted decimal 255.0.0.0, we want to reverse that, which is a wildcard mask. So reverse that would be 0.255.255.255, and then OSPF can be divided into different areas, and they advertise specific routes in the certain areas. So not every router on your entire network, if you have a large one, is holding an entire database with every single route that can just get shared between the areas when needed. But that's for multi-area OSPF. We're just doing single area, so we're just gonna put all of these networks in area 0. So there's our 10 network, and then the network for our loopback interfaces, 192.168.0.0, and we're just gonna apply a /24 wildcard mask to that, so 0.0.0.255 and area 0. Okay, so we got that set up. Now, when OSPF was initially implemented, our highest bandwidth speeds were 100 megabits per second. So its algorithm sort of adheres to that and we want to change that reference bandwidth for the algorithm that it uses to accommodate 4 gigabit speeds now. So we can change that reference bandwidth in the algorithm by using auto cost and then a reference bandwidth command. We're going to do 100,000, and that is the max number that it will reference, and that should cover up to 100 gigabit speeds. So because we're doing this, it can pick up on those gigabit interfaces and apply the correct cost to it, so we can figure out the shortest path far easier. So we did that. We changed the reference bandwidth. I'm going to apply this configuration to the other 4 routers, but for the sake of the video, I'm just going to pause and come back, and then we can get started on the OSPF cost and load balancing. Hey, so we finally got done configuring the rest of our routers with that one configuration. So now, in order to ensure a few things, I did a couple of commands before we started. So I want to go through those real quick. So right here, I started off with the show IP OSPF neighbors command. It's shortened. You can press enter and it'll still pick up that is the command. But as you can see, it has formed adjacencies with R5 and R2. These are the loopback interfaces of those routers, and it is in a full and BDR state. So it's picked up the OSPF routes from those routers, and then you can view the OSPF database with the show IP OSPF database command. And as you can see, we have all of our loopback interfaces and the IP addresses for the interfaces and the other routers within the network topology of OSPF. And lastly, the big one, show IP route. So this is going to show our entire routing table, and as you can see, we have the connected and local routes right here. If you don't know what any of these mean, you can look up here. It gives you an idea of which ones mean which. For the O, that's OSPF, and we learned these routes via that protocol as indicated by the O next to all of these routes. So as of right now, the 10.1.1.0 network is load balancing between these 2 interfaces. So we have R2 and R5. We want it to load balance traffic to this network over here. Right now it's doing it through this interface on R5, but we want to do it through this one as well. So what we need to do is we need to adjust the cost here. So right now it's at 3,000, and since, like I was saying earlier, this is fast Ethernet, with that reference bandwidth and the algorithm, it's going to apply 1,000 cost on each outgoing interface to this network. So for here, because it's not going through this interface, we have 1,000, 2,000, 3,000, and then 4,000 on this outgoing interface in total. Obviously that is less than 3,000, or I mean more than 3,000, excuse me. So we want to make the cost going this way equal 4,000. Right now it equals 3,000. So what we're going to do is we're going to adjust the OSPF cost on each of these 4 interfaces. So in order to do that, we go into global config, and then we specify the interface that we want to change the cost on. So F1-1 for R1, and then IP OSPF cost. And we're going to do 1,500, and that makes sense when I explain it here. So we got 1,500 outgoing here, and then it's another 1,500, so 3,000 out this interface. And then this one is still going to stay at 1,000. So we got 3,000 and then 4,000 right up here. So there's an equal cost there that way. But we also want it to have an equal cost of 4,000 on the way back as well. So we're going to need to apply 1,500 cost to this interface. So we have 1,500, 3,000, and then 1,000 to whichever way the packet is going to go out this end. All right, so we got that explained. Now we're going to configure the interfaces with the costs. So R1 is done. Then here, we're going to use the int range command, which you can specify more than one interface with that. And we're doing the 0, 0 and the 0, 1 interface. So do that, and then IP OSPF cost 1500. That's applied. And lastly, on R4, we have the F10 interface. All right, so we got that. And then IP OSPF cost 1500. All right, now that that's done, we want to go back to R1 and review our routing table again. So do show IP route. Let me expand it a little bit so we can see that it's load balancing a little better. And there we go. The 10.1.2.0 network right here is load balancing between R2 and R5. And the cost is equal to 4,000. So going from here, we want to do our default route injection in order for these routers to know where to send packets that don't adhere to any of these addresses within the OSPF topology. So by doing that, we need to create a default route on R4. So I'm going to go back to R4 here. And also in my initial configuration, the 203.0.113.0 network was not advertised. So first and foremost, we want to advertise that route. So I'm going to go back into router OSPF process ID 1, advertise the 203.0.113.0, and give that a /24 mask, so it's wildcard 0.0.0.255, and then place it in the same area 0. And then over on this interface, we want to manage that to be a passive interface. We don't want this interface to advertise any of the routes that it knows about on this end out to here or even out this way. So in order to do that, we need to do passive interface and then configure the interface f1/1. All right, so we configure that as a passive interface. And then lastly, what we want to do is create a default route. So we go IP route. This is the command for a static route, but the special thing about this is the default route is 0.0.0.0 and then 0.0.0.0 mask. So what this is telling the routers is that, hey, like if there's no destination IP that matches any of the ones within this network topology or that are advertised on the OSPF routing table, we're going to send it out to this next hop address, and that next hop address is the one going out to the internet right here. So we got 203.0.113.2, and we're going to configure that. And then what's awesome about OSPF, or just routing protocols in general, dynamic routing protocols that is that you can just inject this route into all of the routers with one simple command. So we're going to go back into the router OSPF1, and in order to inject this default route into the routing table, routing protocol, whatever you want to refer to it as, we use the default information originate command and press enter. So that'll inject it into every one of these routers, and it should show up on the routing table. Let me expand this again. Do show IP route. And as you can see, we're advertising that 203 network and then have an external route labeled by that E2 thing. With the 0.0.0, the default route, and that's getting load balanced through R2 and R5. And that is all for this recording, folks. Thanks for stopping by.